Hi, Algebra 2A students. Welcome back to the fifth and final lesson for Project 1. In this lesson, Prince Digit has learned from one of the scientists that the difference of the squares of two integers is the length of one leg of a right triangle. Twice the product of those two integers is the length of the other leg of the right triangle. And the sum of the squares of those two integers is the length of the hypotenuse of the right triangle. But he's not convinced and he wants to prove it. So we're going to work with him on proving that. So thinking about that quote up there, let's see if we can figure out what that really means. If we've got a right triangle, okay, A, B, and C, okay, and we are told that one leg is the difference of squares, okay? So one of those legs has to be the difference of squares, which would be, oops, let's do that. So it could be either A or B has to be the leg, so it could be either of those, okay? The other leg has to be 2 times those integers. So the other leg has to be 2xy, okay? So it looks like this first one might fit the bill, all right? And then the last one is going to be the sum of the squares, okay? So that will work, but remember your legs of a right triangle are pretty interchangeable. So we also need to look for A equaling x squared minus y squared and B equaling 2xy. So it looks like, and then C would still be the sum of those two squares. So that's what they're really saying here. They're just asking you to kind of simplify what is in words to maybe put it in mathematical language. So A is one leg, B is the other leg, and C is your last leg, all right? So hold on to those as we move on to the next problem here. And knowing that we've got one leg being x squared minus y squared and the other leg being 2xy, if we think back to a certain theorem, we can figure out what that last leg is. So what they say here is let the length of one leg be A, the other leg be B, and the final hypotenuse be C, and let x and y represent those two integers. Which equation correctly represents A plus B, A and B and C in terms of x and y? So we already identified that A was going to be x squared minus y squared, B was going to be 2xy, and C is going to be x squared plus y squared. So now we need to put them in terms of a theorem that we already know, which in terms of right triangles, hopefully everybody remembers, is the Pythagorean Theorem. So the Pythagorean Theorem says that A squared plus B squared equals C squared. So if A equals x squared minus y squared, and B equals 2xy, and C equals x squared plus y squared, we need to square all of these values. So we would have x squared minus y squared squared plus 2xy squared equals x squared plus y squared squared. Okay? And it looks like this is the only one that matches that. Scrolling down, and then we already decided that it was the Pythagorean Theorem for question B there. Okay, question 3. Prince Digit writes a two-column proof to show that x squared minus y squared squared plus 2xy squared equals x squared plus y squared squared. Funny, had you read ahead, you could have just gotten it from there. So here's his proof. And the cool thing is that we are given his reasons, so we can just follow through and work through that, okay? So the first thing that we do is the binomial expansion, which just means that we need to expand this one. And when we do that, if I square x squared plus y squared, I get x to the fourth minus 2x squared y squared plus y to the fourth, okay? And then I've still got plus 2xy squared, okay? So let's see, that binomial expansion, I'm not sure if they include that 2xy squared there. Yeah. So this should be my blank one, okay? And oops, I had minus. We're going to correct that. We're going to take that away. See if I can undo that. This should be up here. Okay, there we go. Should be the minus. There we go. Okay, so that was my binomial expansion. And then the power of a product rule is going to be expanding this little guy. So we're going to have x to the fourth minus 2x squared y squared plus y to the fourth equals 4x squared y squared. So that's, or excuse me, plus 4x y squared. 4x squared y squared. So that is not an equal sign there, but that is my power of a product. So I can scroll down and find that. Blank 2. Okay. And last but not least is combining like terms, and you'll see that these two terms combine. So I have x to the fourth plus 2x squared y squared plus y to the fourth. Okay. Blank 3. And then last but not least is factoring, and this actually factors quite nicely into x squared plus y squared squared. Okay, so that is the proof of what we're doing there. And if we scroll down to number 4, now they want us to come up with x and y values that would fit into those equations where a squared plus b squared equals c squared, where a is x squared minus y squared, b is 2xy, and c is x squared plus y squared. So, I happen to know which values they are, and I'm just going to kind of walk you through those. If I have x equal 1 and y equal 2, okay, then a is going to be x squared minus y squared, which is 1 minus 4, which becomes negative 3, okay? B equals 2xy, which is 2 times 1 times 2, which is 4. And C is x squared plus y squared, which is 1 plus 4, which is 5. Okay, so then I also have to show that this works because a squared plus b squared has to equal c squared. Okay, so 3 squared is 9, 4 squared is 16, and 5 squared is 25. So 25 equals 25, which means that x equal 1 and y equal 2 work here, okay? There is one more value that works for this, and that is x equal 3 and y equal 5. So A is going to be x squared minus y squared, which is 9 minus 25, which is negative 16. B is 2xy, which is 2 times 3 times 5, which is 30. And C is 9 plus 25, which is 34. Okay, now I have to say that negative 16 squared plus 30 squared equals 34 squared. And negative 16 squared is 256. 30 squared is 900, and 34 squared happens to be 1156, which gives me the same answer. Okay? Okay. Last but not least, you're asked to think about these and expand on it. Okay, the difference of squares of two integers is the length of one leg of a right triangle, twice the product of those integers is the length of the other leg of a right triangle, and the sum of those squares of those integers is the length of the hypotenuse of the triangle. How can we generalize this? And try to do some research on the internet about this statement, which is known as Euclid's formula. And basically, what we are trying to convey here is that Euclid's formula can be used for generating Pythagorean triples, which Pythagorean triples are three positive integers, a, b, and c, such that a squared plus b squared equals c squared. So it's just kind of connecting Euclid's formula to the Pythagorean theorem. Okay, I think that is it. I thank you again for joining me. Now that you have finished the Lesson 5 project, you can submit Project 1. And if you've been watching these videos, you should get a very good grade on it. Thank you.